Righto people, we've got some relays to look at in this lesson. Here are a few that I've dug out of my collection. Now, they all look a bit different, but they all do exactly the same thing, guys. Let's take a look. I'll pick this one out to start off with. Now, this is a single pole relay. We can see it has terminals at the bottom here and at the top here. But what wires do we connect to these terminals, and how does this thing actually work? Well, to answer that, let's flip it over to get a better idea. Okay, that's a bit easier to see everything. Now, firstly people, this relay is actually two separate parts connected together. Check this out. We can see here that this part is the actual relay and this part is the base. All the main parts of the relay are up in this part here, while the base is just there to hold the relay and provide a path for the electrical signals in our wires to get from the terminals to the unit itself. This is where all the magic happens. Another reason they are separated is so that the relay is easily replaced if it burns out. Okay, so how does it work then? Well, it works on the same principle as the contactor that we looked at earlier. It has a coil that we can see here at the top on this side, and a set of contacts that we can see here. Now, when the coil is de-energized, that is to say that there is no voltage provided to it, the contacts are in this position here. When we provide the correct voltage to the coil via these terminals here, which in this case is either 24 volts AC or DC with this relay, the coil will energize and switch the contacts over. So again, when the coil is de-energized, this will be the signal path through its normally closed contact here. And when the coil is energized, the contacts will switch over and this will now be the signal path through the relay here. And that's pretty much it on the operation of things. In terms of ratings, you just have to take a look at the specifications on the unit to see if it suits your needs. Here, we can again see that the coil voltage is 24 volts AC or DC, and the contacts can handle up to 6 amps at up to 250 volts AC or 30 volts DC, and up to 2 amps at 400 volts AC. Now, we know how it works, but what would we use one of these things for? Well, a relay is very helpful when you want to use one particular voltage, for example 24 volts, to switch another voltage of, let's say, 240 volts AC. And this is where it's going to start to make sense, guys. Check this out. If we are using 24 volts here to switch 240 volts here, what can we do with this 240 volts? Like, what's the point? Well, we can turn something on that needs 240 volts. What can we turn on? Like, I don't know, how about a contactor that has a 240 volt coil? Let's check that out. Let's connect it up. And obviously we connect through our fault contacts on the overload first. Remember that lesson, guys? Check it out. It's all starting to come together. We're using 24 volts to energize a relay that will then switch 240 volts through to a contactor, which will then switch on a motor. Okay, I'm getting too excited. First, let's finish off relays, and then we can move on. Now, let's just have a look at those other relays. What's the difference between the one we just looked at and these two? Well, not much really, guys. The main difference is this relay is a single pole relay as we've already stated earlier. And these relays are 2-pole relays. So when these relays are energized, they switch 2 sets of individual contacts as opposed to the 1 set of contacts when this relay is energized. Now, relays can come in all sorts of shapes and sizes, from single pole to 2-pole, up to 8-pole, I think, maybe even more. And their coil voltage can range from a few volts AC or DC up to hundreds of volts. But their principle is always the same. They use a certain voltage at the coil to switch at least 1 set of contacts. And that's it. Easy, guys. Lesson done. Cheers.